Question number 1, part A.
There's a decreasing. Yeah. Okay. So first it'll be copper, and then it'll be iron, and then it'll be probably it'll be no wait. Aluminium. Oh
Decreasing
yeah,
reactivity
aluminium.
means most reactive come first.
Yeah. So first it'll be copper, and then it'll be iron, and then it'll be sodium. No, aluminium, and then sodium. Yeah.
Okay. So sodium, aluminum, iron, and copper.
Yeah.
Decreasing reactivity, sodium most reactive, and copper being least reactive. Let's start with part B, part 1.
So magnesium mixes and it is strong level reacting producing a lot of spark and so the limit of this reaction. Products, sir, in which sense?
The products, the chemical
Yeah.
reaction, what products would the chemical reaction give? Definitely, it's understandable. It's a displacement reaction. There is going to be an oxidation reduction reaction. So, how would we do it then?
Uh, Peroxide and
It's better if you, instead of thinking it, take a pencil and a piece of paper, try writing these as symbols and forming an equation. Not only would you be able to solve part 2, you would also be able to solve part 1 instantly, because you'll write the symbols of the product, so you'll have the balanced chemical equation, as well as you're going to have the name of products with you. So it would be a good practice.
sir,
Sometimes the redox reactions are better if they're written instead of doing them orally.
but I think magnesium will displace like copper oxide. I mean copper, and then it'll
Hmm.
be magnesium oxide,
And
and it'll then
there
copper
are
will
two
be
products, magnesium
yeah.
oxide and copper. Perfect. So now you know it's magnesium oxide and copper. Go ahead and write the balanced chemical equation. I'm going to give you the annotation capability. Go ahead. You can send it to me through picture. You can annotate it on the screen, whatever you like.
Alright, copper. Sir, should I mention the ions as well?
There are no ions.
No,
This is
like
a balanced symbol equation. You're not supposed to write ionic equation, which means you'll only have compounds and elements, no ions.
alright, okay.
This should be easy. Are you done?
Yes, sir.
Okay, so what are you planning to do? Annotate it on my screen or sending me the picture?
Sir, I'll send you the picture.
Okay, okay, good, go ahead.
Uh, I'm not sure how to balance this, but I tried, okay. Uh, Sir, I think it's wrong, but okay. I have sent.
Okay, yeah, I just received the picture. Okay, you already solved it for oxidation and reduction. Guess you have done part two, three along with it. Not four, but two and three. So we have magnesium and we have copper oxide, and then we get copper, and then we get magnesium oxide. Okay, perfect. Now, what's not right is that copper isn't losing electrons or magnesium isn't gaining electrons. Okay. Hmm. I guess you're having a hard time with the oxidation reduction rules. All right, let's do it over here. So we have solid magnesium and we have copper oxide solid, and then it turns into magnesium oxide ash, which is again solid, plus it gives us solid copper. Now, first things first, This is the balanced chemical equation with the correct state symbols. Number two, when you put up a line or an arrow, this should hint from one element to the same element on the left and right. It shouldn't hint in the center. An arrow in the center, an arrow above oxygen isn't right. For example, if I need to take an arrow, I'll take it right out of Cu and I'll take it all the way back to Cu again. That's how it works. You won't see any arrow on top or at bottom of oxygen. Why? Because the oxygen does not change state. Now, as far as the states are concerned, a single element, a single alone element is always zero. So this is going to be zero. Let's do it with a different color so that it's easier for you to understand. So zero and zero. Why? Because they're single atoms. Make sense?
Yeah.
Okay. So magnesium most of the time is 2 plus, which tells us oxygen is 2 minus. If the oxygen is 2 minus on both sides, the copper must be 2 plus. So now try and understand the point that magnesium is going from 0 to 2 plus and copper is going from 2 plus to 0, which means magnesium from its neutral state lost 2 electrons. You can even write it with a minus sign, that's fine. And copper was already lost with 2 electrons, became neutral by gaining 2 electrons, the exact 2 electrons magnesium lost. That's why the oxidation induction. Now, with another color, lost 2 electrons means this is oxidation, right? And gain of 2 electrons tells us that this is reduction. Now, to be more direct and precise, oxidation means this is a reducing agent, right?
Yeah.
And reduction means this one is the oxidizing agent. Now, this clearly tells us that if I write this one as oxidizing agent and this one as reducing agent, I'd be correct. Make sense?
Yeah. But
Now,
sir,
you are
why
definitely, yeah, go ahead.
why did you take magnesium as zero and copper as well?
Right. The big $1 million question. Yes. Now you are having a hard time what numbers to put on which element, right? When you write an
Yeah.
equation, you get lost on how do we put the oxidation numbers or oxidation states on the top of elements. You're having a hard time with it, which means we need to understand that first. Okay.
Yeah.
So what I'm going to do is that for a while, I'm not going to go with the book since it's not explained well in the book. We're going to go off book. We are going to go with, um, let's say, I guess I have some pages already written with oxidation reduction tips with me. So let's go with those pages. And I'm going to explain oxidation reduction rules to you first so that these equations become easier to you.
All right.
Okay.
Yeah.
So are you good with this equation? Can I raise it?
Yeah.
All right, great. Now, okay, this starts with types of reactions. Yeah, you have all these types of reactions in Edexcel as well, but they are scattered throughout the book. This is going to definitely help you. This is not written by me. This is written by one of my students. So there might be a few mistakes here and there. All right. Since we do not get concerned with the type of reactions, I'm not going to discuss that. And we are going to move a few pages ahead. And we are going to directly jump to the page where we have oxidation reduction. Now, the 13th and 14th type of reaction is oxidation reduction. You can see addition of oxygen, loss of electron, but you see two more definitions. Yeah, there are about four different definitions for oxidation and four different definitions for reduction. Now, let's not confuse ourselves with extra definitions since we only go with definition number one and definition number three in Edexcel. Let's stick to that. Right now, it's not the point that we do oxidation reduction definitions or the definitions for a redox reaction. We already know how to do that. So let's get to what we are supposed to do now. Now, since you get stuck with oxidation state and how to put the numbers, so we're going to stick to that. Okay. Now,
Uh-huh.
oxidation state is an apparent charge on an atom, molecule, species, whatever that is. The charge on an ion is usually known as valency. So in order to differentiate the apparent charge, we use the bigger, broader term, oxidation state. Now, I hope you understand. In order to better explain it, I would say that we have studied three different types of bonding. There was ionic bonding, which was made up of ions. There was covalent bonding, in which we shared electrons. There never were any ions in there. And lastly, there was metallic bonding in between metals, right?
Yeah.
So in ionic bonding, we formed ions. Ions had a specific charge on them. For example, if I be accurate, chloride ion had a negative charge on them. Hydrogen ion usually had a positive charge on them. Oxide ions had a two negative charge on them, like that. Now, these charges are commonly known as valency. Why? Because these are the charges on ions. How do these charges come on them? They happen after either the loss of electron or gain of electron. I hope you properly understand from your bonding chapter that a positive charge comes when an atom loses one electron or more than one electron. I
Uh,
hope you also remember a
yeah, yeah,
negative charge is usually written when an atom gains one electron or more than one electrons. It may gain two, it may gain three, really depends, right?
yeah, yeah,
So I hope you understand this is all valency. We do not write these plus and minus signs when we're talking about covalent compound. For example, water is a covalent compound. Now, water is made up of sharing of electrons, which we usually show like this, right? We
yeah,
do show them with single lines, single covalent bonds, double covalent bonds, triple covalent bonds. We show them like this. We never use positive and negative signs in them. But what if we need to define them with charges? How would we do that? Now, there is no charge on covalent compounds. So what we tend to do is that we try to show the apparent charge for our own ease. We even give charge to water, right? What do?
yeah,
We put a minus 2 over here. For oxygen, we put a minus plus 1 over here. We usually multiply it by 2 since there are two atoms for hydrogen. That's how we write it. So that writing for our own ease, this is for our own ease, we call it oxidation state. Now there are certain rules for writing those numbers. And here we have the rule. Now I'm about to explain how to put a specific number on a specific atom. How would you know which number to put on which atom? So let's go through the rules. The generic rule. As soon as you see an atom, locate it in the periodic table. It would be one of these eight groups, right? For our
yeah,
own ease, what we do is that we usually tend to put plus one on group one elements, plus 2 on group 2 elements, plus 3 on group 3 elements, usually plus 4 on group 4, minus 3 on group 5, minus 2 on group 6, minus 1 on group 7. We write 0 on top of group 8 because these are noble gases. They have their shells. They really don't need to lose or gain or share electrons, right?
yeah,
Now, out of these, non-metals also show variable oxidation states. Non-metals can show different oxidation states than what's written over here. How would you know that? Let's discuss that in upcoming points. Is the point number one clear?
yeah,
It's easy. As soon as you see an element, go back to the periodic table on your paper, locate the element, locate the group, give the number. Easy enough. Sometimes non-metals, which is usually group 4, 5, 6, 7, which are underlined over here, they show variable oxidation states. In order to cater that, let's go in the upcoming points. Now, oxidation states for all transition elements are variable. I didn't think you should write all. Most transition elements, okay? Oxidation states for most transition elements are variable, which means they can vary, okay? Let's forget that for now. We'll do this one a little later. Let's not do that now. Oxidation state for single uncombined atom is always zero. Because of this rule, I was able to put zero on top of magnesium, zero on top of copper. This is the rule that I followed. That's how I know if there is single uncombined atom. Uncombined atom means an atom which hasn't combined with any other atom on the planet. It's single, it's alone. So yeah, magnesium or all the atoms along with it are of the same type.
Yeah.
Okay, great. So oxidation state for diatomic molecules, the simpler molecules that we studied back in covalent bonding, such as H2, F2, Cl2, Br2, I2, O2, N2. There are 7 diatomic molecules which we usually teach in IGCSE. That's about it. That's all you're going to study in terms of diatomic molecules. The ones, at least the ones with the similar atoms. So they all have the zero state. Why? They're still the atoms of the same kind. So H2, 0, F2, 0, Cl2, 0. It doesn't even mean that. It means that O3, it has all the same elements, 0. P4, it has all the same elements or atoms, 0. S8, atoms of the same element, 0. So this is what the word uncombined suggests, right?
Mm.
If an
Yeah.
atom is not combined with any other atom, with a different atom, no matter how many number of atoms are there in the formula, we always take the state as zero. Are we good with first 4 rules?
Yeah.
Good. If we're good with these, let's move on to the fifth one. This definitely requires some explanation. Now, oxidation state of a compound is also equal to zero. That's how sum of oxidation states of all elements in that compound will be equal to zero. Notice, NaCl is a compound, the table salt we eat every day. Now, it is composed of 2 different atoms, Na and Cl. If we take their oxidation states and if we simply add them arithmetically, what we commonly do in maths, the answer should be equal to zero. And this is true for every compound on the planet, no matter which
Uh-huh.
compound is that. Carbon dioxide, water, magnesium oxide, copper oxide, name a compound, and the sum of oxidation states of all the elements in that compound would always be equal to zero. That's how the compounds are electrically neutral.
Yeah.
Okay, take an
Yeah.
example of water. All right, oxygen tends to be -2 all the time. Hydrogen, which would be the last point on this list, hydrogen is usually equal to +1 its charge. Oxygen is usually equal to -2. Let's put these charges up top. So oxygen is 2 minus, hydrogen is 1 plus. Now, since there are 2 hydrogen atoms, so we are supposed to multiply this charge over here. Now put that into an equation. 2 into +1 plus -2 is equal to what? Solve it, your answer would be equal to 0. That's what this point means. If you sum, if you add, which I did over here, all the oxidation states of all the elements in a compound, the answer would always be equal to 0. Now, since we already know the answer is always going to be equal to 0, we use that to our own advantage to find out the unknown oxidation states, right? I just
Mm-hmm.
said copper state can vary. Now, this is copper oxide. Previously, I wrote this as 2 plus and 2 minus for copper and oxygen. There is another copper oxide present, right?
Uh-huh.
Okay. Now,
Yeah.
this clearly tells us that even if the oxygen is still -2, copper might be a little bit different. Now, we don't know what copper is. So what do? We put it as X. And since there are 2 atoms of X as shown over here, it would be 2X. Now we already know if we add this up, 2 into x plus -2, we already know this is going to be equal to 0. Solve it, you'll get the answer of x equal to +1. Solve it mathematically, you'll get this answer. How? Let me solve it for you. It is going to be 2x minus 2 is equal to 0. It is going to be 2x is equal to 2. It is going to be x is equal to 2 over 2, the answer to which is 1. So x is equal to plus 1. Actually, this point is a huge helper to find out the unknown oxidation state for any any atom. That could be a metal, that could be a non-metal, that could be a metalloid, that could be anything. Understandable?
Yeah.
Great. If you understand this, move on. I usually ask my students to practice this point. I'm going to ask you to do the same, but I'm going to explain you a couple of points first. Let's wind this one up, and then we're going to practice it. Okay. So
Yeah.
moving on, oxidation state for an ion, it is not an anion, it is anion. These are two separate words. Oxidation state for an ion is equal to its charge. So let's suppose sulfate ion is like this. So the oxidation state for this one is going to be equal to minus 2. This is not going to be equal to 0. For an ion, this is equal to its charge. Let's say we need to find out the state for sulfur. We know the state for oxygen is minus 2. I've been saying it all along. What would be the state for sulfur? Let's solve it over here. So SO4 has a charge of minus 2. I have been saying I'm going to use a different color that oxygen is minus 2. Since there are 4 atoms, we multiply it by 4. And sulfur, we don't know. We're going to put it as X. So the equation would be X plus 4 into minus 2. Since there are 4 atoms of oxygen and the state of oxygen is minus 2 is equal to what? Now, we're not going to put it as 0. This is the point. This is what this point is all about. We're going to put it as minus 2. Why? The charge on the ion is equal to minus 2. So let's solve it. So x is equal to minus 8 is equal to x minus 8 is equal to minus 2. X is equal to 8 minus 2, which is equal to plus 6. So this means s is equal to, which actually is s, is equal to plus 6 in this case. Make sense?
Yeah.
So this is another point we need to practice. We're going to practice this one surely. Oxidation state of hydrogen, H2, 0. Most compounds, hydrogen is equal to plus 1. Hydrides, something not discussed in Edexcel, so let's forget it. Hydrogen is going to be plus 1 in most compounds, but H2, hydrogen is 0. So there we go. We also catered hydrogen. So now you know for the whole periodic table.
Mm.
Let's work out some examples. Okay, if we go any further, they directly jump to equations. I'm not going to directly jump to equations. I'm going to first lay out the basics for you, compound by compound, ion by ion, and then we're going to go for an equation. So I'm going to stop sharing over here. Let's practice a couple of compounds first. Remember, the simple rule was sum of the oxidation states of all the elements in a compound was equal to 0. So starting off with the first example, NaCl, now we know Na is equal to plus 1, Cl is equal to minus 1. This one's easy. So if I write NaCl, you know this is going to be 1 plus, this is going to be 1 minus. So plus 1, minus 1, and if I add both of these up, would be equal to 0. But that's not how we use it. We usually use it to find the unknowns value. For example, copper iron tends to make an oxide with oxygen, FeO. Now, if I tell you the state for oxygen is minus 2 or 2 minus, what is the state for iron? How would you find it? So it's pretty simple. You're going to write it like this. If oxygen is minus 2, we put this one as x. You can put it as x, you can put it as Fe. It's entirely up to you which variable you use. So x added to minus 2 charge is equal to 0. This proves x is equal to plus 2, and that means Fe is equal to plus 2. There you go. You've got your answer. Now, what if the number of atoms are different? Let's take another oxide of iron, Fe2O3. Now again, we know oxygen is equal to -2, but this time we need to find Fe, and definitely iron, since it's a transition element, it is the center of the periodic table, it has changed its oxidation state. Let's find it out. So we write Fe2O3, this is 2, this is 3. Now we know the charge is -2, but we write charge inside the brackets, we write the number of atoms outside the brackets, we write the unknown charge as x inside the bracket, we write the number of atoms outside the bracket. Let's form an equation, 2 into x plus 3 into -2, and we know the whole thing is going to be equal to 0. Let's solve it. It would be 2x minus 6 is equal to 0, which means 2x is equal to 6, x is equal to 6 over 2, which means x is equal to plus 3. This plus 3 is now the charge of iron. So previously, iron was plus 2, if you notice over here, and here it proves to be plus 3. So definitely, iron being a transition element is changing its state. You get the point?
Yeah.
Now, if you do get the point, let's use these and find out the unknowns. So let me give you a few questions. Okay, so your question is find out oxidation state of N, which means nitrogen, in the following. Now for your E's, okay, I'm going to tell you that hydrogen is going to be +1 in both cases. Sodium is also going to be +1. Potassium is also going to be +1 in the upcoming questions, and oxygen is going to be -2, right? So the questions are NO, NO2. I'm going to give you a few parts to solve. N2O3, N2O4. Now you see how many different oxides can nitrogen form. This is going to be amazing for you, and you're going to have an idea how many possibilities are there for non-metals to form different compounds. Okay, N2O, and then we have 7 HNO3, 8 NaNO2. I guess that's about it. We're good with 8 parts. Yeah, this is the 8th part.
Sir, for the first one, uh,
N is equal to?
-1.
No. Charge on oxygen is -2. So N must have the exact opposite charge in order to balance it. So if O is minus 2, N must be equal to plus 2. This is only going to work if you're good with algebra, math.
No, sir, because in at the top you give like hydrogen as plus one and then Na as plus one. So from there I took.
Hmm? But it
Uh,
just has N and O in it. Why would you take the state of hydrogen? The formula doesn't even consist of hydrogen.
no,
It's
sir,
just
not
nitrogen.
hydrogen. I took Na plus one.
That's sodium. Na is equal to sodium. Which part are you solving? Part 1?
Sir, my bad. Okay, let me do it once again.
Okay. Although I didn't get the error, but if you have spotted the error, go ahead, correct it. That's fine.
Okay.
Let me tell you, NO, which is part 1, is literally solved as the second example over here, FeO. If I put this one as example number 1, this one has example number 2, this one has example number 3, it is literally similar to example number 2.
Mm. Sir, is it fine if you give this as homework?
I don't mind.
Yeah, because
Do you
I
want
think
me
I have.
to extend
Yeah.
this as homework, or are
Yeah.
these 8 parts good enough for you?
No, I'll do it. You can send me as homework.
Okay.